loud. A can of soda, a 550 gram. Okay, first thing is that's going to get converted to kilograms. How do I convert 550 grams to kilograms? Kilo is 1,000. Do I times by 1,000 or do I divide by 1,000? Here's how I figure it out every time, Evan. I've done enough driving to know kilo is 1,000. I take 1 gram. I know that 1 gram is about a paperclip. If I times by 1,000, that would mean 1 gram is 1,000 kilograms. Is that possibly correct? 1,000 kilograms is like a car. That would say that 1 gram was the same as a car. No, it's not times by 1,000. What is it then? Divide by 1,000. So if you divide by 1,000, you'll get 0.55. You can put the 0 if you want to. I didn't. Kilograms. Okay. Is thrown due? What's the word after the word due? Soon as I see a direction, now my spider sense is perking up. I'm going to look, if I see a west somewhere, I'll let that be negative. In fact, what I'll do right now is I'll put a positive right there. A 12-gram bullet, nice try. 0.012. Traveling west. What am I going to put in front of this 250? Negative. Strikes the can, passing through it. Afterwards, the bullet continues west. Negative 55. What's the final velocity of the can, magnitude, and direction? I really encourage you, Riley, to take the time to put the pluses and minuses in before we start. If you do that, then as long as you're careful, the question will take care of itself. Is there a collision in this question? Is there more than one object? It's going to be conservation of momentum. I always start out by writing this version of the law of conservation of momentum, that strange sigma symbol. Momentum initial equals that strange sigma symbol. The sum of all the initial momentum equals the sum of all the final momentum. If you skip that step, I'm not going to freak out, but often I'll give you a half mark on a test if I see that and you can't remember anything else. At least I'll say, oh, you knew enough to know that this is a momentum conservation of momentum question. Before the collision, is there more than one mass in this question? I could use A and B. How about C for can and B for? You don't have to use A and B if you don't want to, Jackson. You can, but if you want to use letters that match what we're talking about, that's okay. Jackson, do you want me to use A and B, or do you want? Okay, Jackson gave me the stink eye, so I'll go A. I'm still using B for bullet. That works. Jackson, before the collision, what's moving? Mass A, mass B, both or neither? And I think they're separate because they have different velocities. So I'm going to have the mass of A, velocity of A initial, plus the mass of B, velocity of B initial, wham, they collide. After the collision, what's moving, Jackson? Mass A, mass B, both or neither? We know mass B is, but what do they want me to find? Of? I think both are moving, and I think separate. Okay? I think what happened is the bullet goes through the can. The can slows down but keeps going. I suspect that we're going to find that the can's final velocity is less than 25. It might even have turned completely around. I don't know. We'll find out. So I'm going to argue mass A, V, A final. There's the can of soda afterwards. Plus mass B, V, B final. What do you want me to find here? Velocity. Yeah, which one? Final. Yeah, which one? What's going to drop down like a domino? The whole left side, yes? M-A-V-A initial plus MB VB initial. Talk to me, Jackson. What am I going to do next? Reverse bed mass. So what am I going to subtract over? Or you could have just said the second term, and I would have figured it out. And then? Yep. And this is VA final. This is a bit trickier because it's a head-on. I'm going to try and make some predictions. It looks like the bullet lost a lot of momentum in the western direction. So I think the can will gain a lot of momentum in the western direction. It might be enough to have the can come to a complete stop and have turned around. I don't know. I see a whole bunch of you already with your heads down typing, so let's plug and chug and find out. Logan, I'm coming to you now. What was the mass of the can? Mass A?
1255.
What was the initial velocity of the can?
12.
That's the initial velocity of the can? That's another mass, I think. Check your units. So now, go find where the can was. How fast was it going to begin with?
250.
Yeah, positive or negative? What did we write in front of that already?
Negative.
We called it negative?
Yeah.
Can. How fast is the can traveling?
25 meters per second. Positive, yeah.
Are you positive? Shut up. Okay. Plus, what's the mass of of B, the bullet? That was 0.012, yes?
Yeah.
And how fast was the bullet traveling?
Minus 200.
Good. And then I have a minus sign and the mass of the bullet. What was the final velocity of the bullet? Keep reading. Hoping I told you. Keep reading. Find the next number.
Minus 55.
And negative, yes?
Yeah.
Because it's west.
Mm-hmm.
And then all divided by mass of A, which was 0.55. I have a tough time believing that this is going to be working out evenly. I'm positive that the can slowed down. So if it's still traveling east, I think it's going to be less than 25. I'm not sure. You might end up with a negative answer. I'm really not sure here. In which case, it would be now going west. I don't know. What'd you get? Sorry?
11.4.
Positive or negative? Positive 11.4. Anybody else? I'm seeing no one else nodding their head. Okay. Adam, what'd you get? Positive or negative? Positive. Positive what? Anybody else? 20.7?
Yeah.
I see some nods. So you want to double check your brackets or your negatives, Kenley? Oh, you forgot to divide Kenley by 0.5. Ah, Adam even diagnosed your issue. Okay. Oh, and we've also probably spotted a very common mistake because you're all so proud that you've done that top line so carefully and you relax and forget to finish off the whole thing, right? Okay. Sorry, what was it, Adam? Hit your answer button, please. That's why you have an answer button. And then hit equals. Oh, have I taught you nothing? So 20.8 or 20.7? If I round off properly, 20.7? Is that right, folks?
Yeah.
Units. Direction. So it slowed down, not by as much as I thought. I thought it would slow down more. Oh, wait a minute. The bullet is really light compared to the can. And so although the bullet was traveling really fast, such a small mass, it really didn't transfer that much momentum to the can. Is this collision elastic or inelastic? That's something you want to get from the notes, Ben, by the way. Because elastic rubber band bounce apart. Inelastic means stick together. Right? Bullet hitting a target can also be inelastic if the bullet sticks in the target. And then it would be mass 1 plus mass 2, mass A plus mass B, V final, right? Okay. Your homework is every question, and also lesson 4 if you haven't finished that. But first, I've lied to you. Momentum is not mass times velocity.